So in section 10.5, we're going to graph polynomial inequalities. To kind of start, it sounds worse than it is. I said graph polynomial inequalities. We're actually just going to solve them. We're not going to graph them. But our graphing calculator can help us out on these. So just to review, because I'm recording this, your setup on your graphing calculator should be this. You hit the second key, then the window key. Make sure that the independent is set to ask and the dependent is set to auto. If it's set to something different, just cursor over there and then press enter. When you're done with that, you can quit. So you can hit the second key, then the mode key, and exit out of there. You'll be fine. We're going to solve in this section quadratic inequalities. So what's that going to mean? Well, we're going to solve stuff like this. 6x squared plus x is greater than 1. Now what's different about this than our usual quadratic? There's no equal sign. We have a greater than sign. And that's going to mean a world of difference here. So Nick, what we're looking for is values of x that I can plug in here that make this thing greater than 1, or equivalently this greater than 0. So, okay. Now the instructions in solving these things say to start by getting 0 on one side. So I'm just going to move that 1 to the left-hand side. And it's this expression right here that I'm going to be concerned with. I'm going to work with a lot. Let's start by putting that expression into our calculators. So hit the y equals key and then type in 6x. So 6x squared, right down here, plus x minus 1. Nice. Now what I want us to do is I want us to do a little t-table and just kind of play around, experiment. So once you get this expression entered, let's do a table. So our table, you should be able to access it by hitting the second key and then the table key. If there's a value there already, let's just delete it to start from fresh. Give me some values. Let's throw out a value for x. Anything. 0. If I type in a 0, I get -1. So does 0 work for us in this? When I put in a 0, I get -1. Is -1 greater than 0? No. Let's try another one. What's another value that we can check? 1. If I put in a 1 for x, I get 6. So is 6 greater than 0? Let's try a couple more. Just a couple more. 2? All right. Really being inventive here. Creative. I like the creative thought. 2 gave me 25. Does 2 work? How about pi? Let's put in pi, right? So to get pi, that's right here. You hit the second key, then the up arrow key. That should put in the decimal value for pi. Once you press enter, you'll see that. But the bottom line, does pi work? Yeah. So there's a lot of numbers that seem like they're working. There's at least one that doesn't work. Your goal, though, is to find the values of x that you can put in there that make it work. And obviously, there's more than one solution. Actually, there's a lot of solutions. So we need to figure out, well, what values do this? And I think by just sitting there and guessing, it's probably not a real efficient way to figure out, well, where it actually works. So let me show you how you can figure out where these things are true. What you're going to do once you get 0 on one side is you're going to set this polynomial equal to 0. So it's going to be 6x squared plus x minus 1 equals 0. Now on your handout I say factor and find the roots. Depending on the problem, you might not be able to factor it. You might have to use the quadratic formula. But what about this one? How would you solve this equation? Are you going to factor it or are you going to use the quadratic formula? I'd suggest you factor it, mostly because it's already done for you right here, right? You could use a quadratic formula if you want to, but let's not. And when you factor it and set each term equal to 0, then we get two solutions, 1/3 and -1/2. And we're going to put those two solutions on the number line. So this goes from -infinity to infinity. And let me put them here and put them on in the correct order from left to right. These two numbers break up your number line into 3 intervals. Let's see if we can't figure out what these intervals are. In interval notation, what's this interval? What's at the left-hand endpoint of this one? Negative infinity to negative 1/2. Negative 1/2 to 1/3. How about the last one? Good, 1/3 to infinity. Thank you. It's always left-hand endpoint to the right-hand endpoint. So make sure that you get those in the proper order. I suspect that if you entered your answer with these in the wrong order, that Newton wouldn't like it. It's going to give you some negative feedback. All right. But the question is, for the values of x here or here or here, what happens when I put these into this expression? Does it make it positive or does it make it negative? Because this is an expression greater than 0, I want to find the values of x that I could put in here to make it positive. So here's how we're going to do that. We're going to take this and test some points. So I need to pick points in each of these intervals. So for instance, what's a test value to the left of negative 1/2? Negative 5. Sure. So let's choose negative 5. How about something between these two? 0 works pretty good. And don't make Sage do all the work. Something, thank you, 6. All right, was I getting the wrong? Was it you? All right, sorry. I just do the direction, that's all. Oh, okay. So I thought I was wrong, but I was merely mistaken. Okay, good. We'll figure out that one later. In any case, we're going to test these in this expression and find out if it makes it positive or negative. There's good news for us. We already have that expression in our calculator. So let's go back here, and I'm going to delete all these values so I can kind of start from scratch. And the values that I wanted to test were negative 5, 0, and 6. Now the stuff that I needed out of this wasn't the fact that when I plug in a 6, I get 221, or when I plug in a 5, I get negative 5, I get 144. What I needed to know was when I put in a value from this interval into this expression, was it positive or negative? And the results from our little test here were plus, minus, plus. So the last part of this then is, all right, well, which interval do I want? Do I want the positive intervals or do I want the negative interval? Well, take a look here. Is this going to be true when this is positive or negative? Positive. We want it to be greater than 0. So my answer is going to be these two intervals, the positive intervals. So negative infinity to negative 1/2 union 1/3 to infinity. Yay. And that's it. A good question would be, well, do I want to use parentheses here or do I want to use brackets? Can I use negative 1/2? Can I use 1/3? Well, let's check it out. Let's check it out with our calculator. If I put in, say, 1/2, or excuse me, negative 1/2, negative 1 divided by 2, as soon as I hit enter, it's going to change this into a decimal. That's okay. So putting in negative 1/2 gives me a 0. Let's think about it here. Is 0 greater than 0? No, it's not true. So should I include that? No, I shouldn't. That's why I'm using a parenthesis and not a bracket. Is because a bracket would be including it, parenthesis doesn't. So we're in good shape there. That's your answer. How are we looking with this first one? This is kind of like your warm-up on these, but we're going to do a lot more. So, are we okay there? Yes, no? Yeah? All right. Let's try some more then. Now, I don't have a nice handout for this one, but it'll work out pretty nice. And hopefully we're getting better at this as we go along. So the next one's going to be x squared minus x minus 30 is greater than or equal to 0. The good thing for us on this one is that we've already got 0 on one side. So we're going to take this expression right here and set it equal to 0 to solve. So x squared minus x minus 30 equals 0. Ashley, how are we going to solve this one? What would you suggest? All right, got a suggestion to factor this one. How would that factor? All right, 5 and 6. And the larger one has to have that sign, so you're right. Thank you. Negative 6. That gives me two solutions. Fia, what would the solutions be? Negative 5 and 6. Let's put those along the number line. Negative 5 and 6. Jaden, help me out. This creates a couple intervals for us. What would those intervals be? All right, negative infinity to negative 5. Good. Last one there's 6 to positive infinity. We need test points in all these intervals. Let me get those after I change the function in my calculator. I don't want to test points with the old function. So let's clear this out. Type in x squared minus x minus 30 into our graphing calculator. From there, I'll hit the second key, then the table key, and I'll delete all these old values. But the big question is, well, what am I going to test? What values are going to fit in each of these intervals? Bless you. So I need one here, here, and here. Which ones are going to fit?